Hi, I'm Clash from FPV, and the Malaysian government has just announced that we are now allowed to cross states. This will be the first trip that I have that I'm going to do some serious photography. I started thinking on how to manage the pictures that I took. What happens when my SD card is full? What if they got damaged? What if they got corrupted? And what if they got stolen? So I did a little digging for something of that sort. What I found is that there is a commercial product that seems to do just that, and it's called a Narbox, or however you pronounce it. The only issue there is the price, which starts at around 300 US dollars. There is another solution, which is to use a USB hub that has an SD card reader, plug your SD card and external hard disk to it, then plug your USB into your OTG capable smartphone. With that, you can use the smartphone to copy the photos for your SD card into the external hard disk. Woof, that is a mouthful. This is the cheaper solution, but for some reason the copy is excruciatingly slow. I don't exactly know why, but I think Android copies the data to the phone before going out to the SSD, but I'm not too interested to debug this. Now, I don't have the money to buy a proper commercial product, and I don't have the patience to wait for a slow as fuck janky ass solution. Plus, charging does not work when the OTG is running, which meant that I couldn't even charge my phone while waiting for the file transfer to complete. But what I do have is some engineering skills, this crucial 128GB SSD from my old laptop, and then I thought, what if I create something that dumps all the photos from the SD card into this SSD? I already have a Nextcloud server running at home, so why not also do an offsite backup to my home? For the brains of the operation, I chose a Raspberry Pi 4, not just because it's the latest and greatest, but also that it has a fast transfer speed with USB 3. This is important as we will be connecting both the SD card reader and the SSD to it. It also has 5GHz Wi-Fi built in, which comes in handy since I prefer to use 5GHz hotspot on my smartphone. While waiting for the Raspberry Pi to arrive, I started on the GPIO board for the project. The GPIO board allows for some very basic user interface. The next part is actually recorded after I came back from the trip, so yeah, just a little bit of FYI on that. Alright, so this is the schematic for the GPIO board. Let's start with this. This is the pin header that allows the GPIO board to sit on the Raspberry Pi, kinda like Raspberry Pi hat, if you know one of those. So that gives us access to mainly, the most important one is the 6 GPIO pins down here to power the output and also get some input via the push buttons. Right, so also we need the ground and the 3.3 volts right here. So down here, basically, this is a push button that's going to be an active low signal to the GPIO pins. And all this is basically overkill in the sense that the LEDs themselves actually don't pull that much current, especially when they are limited by the 1K ohm resistor. But this is an N-channel MOSFET doing the job of a switch, an electronic switch, I might say, which gets a signal from various GPIO pins. So when the pins go high, LEDs go bright. Right. Same goes to this guy, which is the buzzer. The buzzer might be draining a little bit more current, but it shouldn't be a problem when they are draining the current directly from the 3.3 volts source. And again, it's being switched by this N-channel MOSFET and controlled by a GPIO pin. Okay, alright, so on to the schematic. Not the schematic, this is the board. This is the PCB board. I have stuff arranged quite neatly, but there's actually 2 mistakes with this. So the first one has to do with this push button. So if you can see here, it kind of differs a bit from what the schematic is showing. I think there's something wrong with the footprint, but yeah. So the mistake was that for the push button to work, when you push on the switch, it is actually connecting between these 2 pads and these 2 pads, which means that this is wrong. Okay, it is connected. It is currently connected between these 2, which means that the switch actually doesn't do anything. Okay, because the circuit is actually closed no matter what. Right. So in the final project, what we will see is I have actually only soldered 1 pad on each side to kind of work around this problem. Okay, the second problem is the placement of this buzzer, which I can show you a more clear picture of that later on. Alright, so this is kind of a 3D rendering of the what the board would look like. Okay, and as I mentioned just now, this is basically the pin header so that it will sit on to the Raspberry Pi itself. Then the orientation of this thing is actually, this would be using the bottom half of the GPIO pins, and this is actually the area where I think this is the USB port, and this would be the Ethernet jack. Alright, so the mistake has to do with this little buzzer right here. So there was a mistake on my part on measuring out the length of the board, and I mean the offsets until the buzzer is cleared. So this actually needs to be a lot longer in this direction so that the buzzer can just hang off the side. You'll see what I mean when I show you the actual project later on. After ordering the PCB and components, I got to work on the script. The script, I put it up on GitHub along with a short video on how to deploy that. Links to those are in the description down below, so if you're interested to make one yourself, feel free to go at it. And also since that this is made in a hurry, there are various limitations and bugs. So if you're a developer and you want to improve on it, please do. Once the Raspberry Pi arrived, I've quickly made some tests and ironed out the major bugs. I mainly tested it out using the Cytron's Maker FAT. And yes, that is actually how you pronounce that thing. I had to hardcode some stuff as the GPIO pins used on the MakerPad is not the same as the one intended on my GPIO board. I've also installed the Nextcloud desktop client onto the Raspberry Pi and set it up to back up the SSD content over to my home Nextcloud server. At this point, the software is ready and we just need the hardware to arrive so that I can finish up. With just a few days from the trip, the parts have yet to arrive. The prototype has already been tested and I thought I would have to just use the project as is. And then the components from Element 14 finally arrived on the morning of the day of the flight, with 4 hours till boarding time. Okay, so I just got it done soldering. So all the items from Element 14 just arrived, and yeah, that's all these MOSFETs right here. So solder it up, and there was a mistake with the buzzer, the PCB length, focus. Yeah, there was a mistake with the PCB length. So the buzzer was supposed to be here and the PCB was supposed to go all the way up here. But never mind. I got it botched in there with just, one leg soldered to the pad and another one just, it's just a watch wire to extend it to the positive terminal. So let's test it out. Sure. Okay, what I got here is just, well, basically just a power bank. You can use any power bank that's sufficient to power up your Pi. Okay, it's gonna be hard to do it one. Alright, okay, just got it plugged in, and as you can see, there's some activity lights going on. Yay. Okay, so let's wait for it to power up. And after power up, it should just run the script that I just wrote. And on initializing, it should just drive everything high for 3 seconds to kind of tell us that the script is actually running. Well, because I was rushing to at least test the entire thing before bringing it out to the trip, I didn't realize that it was the power bank that was not able to power the Raspberry Pi due to insufficient current. I kept debugging and checking if there was something shorter or some sort of problems, but I couldn't find any at the time. Unplugging and replugging in the power didn't seem to do anything, and the green activity LED always seemed to die out after a while. I was short on time, so I just packed up everything and left for the trip, hoping for the best. Alright, so this would be the actual first test in the field of this, portable ingest machine. This portable ingest station in action. So as you can see, I am in my hotel room, and so we're gonna test it out. So I have taken quite a few pictures today, and let's just see if this this project actually works. Alright, so what I have here is, this is just, a power adapter that plugs into the wall. Okay, and then I'm currently charging my phone, and I have one USB-C cable that's meant for the Pi. Okay, so sorry for the terrible lighting. There's only one light for the entire room, so please excuse me for that. Okay, so what we have to do is, this is the Pi, and I have the SSD right here, so let's just plug it in. Right, and this is just the SD card reader with today's SD card that the SD card that I use for today's shoot. Okay, already plugged in, so let's just put it in there. I can do this after it probably works if I plug this in after I boot up, but well, let's just make sure that it works. So SD card is already in there, so let's just apply power. Okay, we have a flashing green LED, and that's always a good sign. So let's just wait for it to boot. Okay, so if it boots successfully, it should beep and all the LEDs light up for 3 seconds. Let's just bring it in. Yep, you guys heard that? Probably. I can check. So it looks like everything working. So one last thing that is missing is that it will actually check for internet connection. Okay, in order to sync back to my Nextcloud server, so I do need to connect it to the an active internet connection. Okay, so but because I have no way to be remote desktop into the Pi to set up to connect to the hotel Wi-Fi. Well, actually I don't have the hotel Wi-Fi anyway. I'm gonna use my phone hotspot. So let's zoom out a bit. So what I have here is, well, my phone. I have pre-configured it to connect to my phone's hotspot, so let's just turn that on. Okay, and it will probably show that. Yep, see? Okay, it's not in focus. So yeah, you can see there is one connected device. Alright, so that will be probably the Pi itself. And as you can see, now the red LED has lit up. So that meant that it is ready to sync back to the home cloud server. Alright, so what I have to do now is basically just press this button. Yep, and you can probably see the hard disk flashing. So that just means that it is syncing. There's an rsync going on between the SD card to the SSD. It is copying everything from the SD card to the SSD. So that I will show the in progress LED, the yellow LED. And when it's done, we will see a blue color LED to tell us that okay, the local sync, the local file sync between the SSD and the SD card to the SSD is done. Okay, and you see this flashing LED. That just means that Nextcloud is actually doing a sync from the SSD to my Nextcloud server. And after the sync is done, after the Nextcloud sync is done, then the red LED would just be a solid LED. Alright, so let's just let it do its thing. Okay, so for some reason my camera just shut off mid recording, probably because I'm using a non-genuine battery. So nevertheless, so that gives us a unique opportunity to test another thing, which is the live switch that I was talking about just now. So I can actually do this by just unplugging it. Okay, so the 3 beeps just means that it cannot find the SD card, so it will just give 3 beeps as a the fader tone, then go back to being ARM to be ready to sync again. So I've switched the SD card. So this is the one that I've been shooting all day, and the one that we just sync before this. So I'm gonna try this one, which I just recorded the video that you were just seeing. Okay. Okay. Alright, So plugged in. It has to, you have to give it a while. The script does not mount the SD card, but the Linux kernel itself mounts it, and I'm just gonna use it. So you can see it detects that there's a new SD card in there, and it is syncing to the SSD. Again, this was the SD card that was just filming, and I mean, this is the one I was just filming the video, and this is the card that I have been shooting the whole day. So yep, it's synced, and now we're just waiting for Nextcloud to do its thing. Yep, it actually worked on the first try with everything correctly soldered. I was very excited that night that it worked, since I was not able to get it fully working before boarding onto the flight. I left my phone hotspot on the entire night and let it back up to my home Nextcloud server, and although I don't have it on video, you just have to trust me that the backup happened flawlessly. So what's next for this project? Well, the first thing I would like to improve on is the UI. It could really be better than just a few LEDs blinking here and there, since there's only so much information that the LED can convey. An LCD or maybe an OLED screen that allows various information like stream progress or how much capacity is left would be nice. Also, I could integrate the SD card reader and the SSD into the project with some kind of PCB to make the entire unit become one single unit instead of having to plug in various USB devices. Another idea that I have would be to integrate a Raspberry Pi based travel router, but that would be a stretch goal. Anyways, here we are at the end of the video. I hope you like what you see, or maybe get inspired to develop something similar yourself. If you do, please leave a like and subscribe, and comment down below on how would you use something like this, or how would you make it better. Thanks for watching, and see you in the next video.